Okay, Assalamualaikum and a very good afternoon. So today we are about to steps in the final part of the chapter 1 entitled Convolution. So for your information, the convolution topic will not be assessed in your test or final exam. However, this topic will be included in your major group assignment. Therefore, you need to understand the basic concept of convolution, understand the process, and also at the end you should be able to compare your output by using simulation tools with the theoretical derivation that will be discussed further in chapter 3 and 4. Okay, convolution is basically a process that happens in an LTI system when you have two functions. Okay, the convolution can be notated as the star symbol. Okay, when you have an input signal, for example xt, going into an LTI system. This is linear time invariant system, and you get the output yt. Okay, so what happened in here in the LTI system itself, it has internal signal, for example ht. So to get yt is basically the input signal being convolved with the internal signal ht. We can see a variety of applications using convolution, for example, the signal processing, computer vision, differential equation, and etc. Okay, this slide shows how a convolution system looks like, in which you have an input signal xt being transmitted over a transmission medium into an LTI system which has an internal signal of ht and then being transmitted to the output or the end recipient. Okay, so in this case, your output signal being mathematically expressed as yt equal to xt convolved with ht, in which can be represented as integration of signal x tau ht minus tau d tau. Okay, so please make sure that when you have an input to an LTI system, so the two signal being convolved, it is not being multiplied. Okay, if you have xt being multiplied with other signal, for example ht, this one is yt, the output signal, so yt is basically equal to xt multiply with ht. Okay, if you have another signal, another system xt into a system, but the input will be delayed by 2 seconds. and you have the output yt. So in this case, your yt is equal to x t minus 2. Okay, but if you have a block diagram like this with LTI system, so that the output yt is produced by having a convolution between the input signal xt and ht. Okay, this slide shows the properties of convolution, in which the signal is commutativity, in which if you perform convolution of x and h, it is basically equal to h convolve with xt. Okay, and the second property is associativity, and the third one is distributivity, in which you will see how the block diagram looks like in the next slide. Okay, this is the first property of convolution, commutativity, in which when you do the convolution of x convolve with ht is basically equal to ht convolve with ht, as represented as the figure below. Okay, for the second property, associativity, when you have an input being convolved for the first time with h1 and then convolve again with h2, it is basically equal to when you have the input signal being convolved to h2 first and the second one to h1. Okay, same goes to when you have double convolution h1 and h2, you can simplify the system by solving the convolution of the two systems first and then perform the convolution of the input signal with the product of convolution of the two systems. So for example, we call this as ht. So convolve with ht, and then you get the final output yt. Okay, the third property of convolution is distributivity, in which you can convolve your first xt with h1t and then convolve again with h2t and then combine them or add them together, and you get the output yt. Or you can simplify the process by adding the two systems first, h1 plus h2. For example, this one equal to ht, so the product yt is equal to yt equal to xt convolve with the product ht. Okay, this slide onwards will guide you how to solve convolution between two signals. For example, if you have RT as the input into an LTI system given by ST, and you get the output YT. Okay, so the first step, you need to sketch the given signal RT and ST. So these are the equation for RT and ST. So sketch these two signals first. So this is RT equal to UT minus 1, and the second one as the equation shown above. Okay, the second step, you need to change the x-axis from t to tau, and then choose one signal to be in fixed position, while the second one will be modified and used for further analysis. So this is the first one, st. So the original axis is t, so now change the x-axis to tau, so now it becomes s tau. Same goes to rt, will be transformed into r tau. Okay, so rt, now it become r tau, so here is r tau. Okay, so in this particular case, you need to decide which one to be chosen as the fixed signal. Fixed meaning that the signal will be staying at the same position throughout the process, while the other signal need to be moved from left to right for a certain duration of t. So in this case, I choose R tau to become the second signal that will be used for further analysis. So in this case, the R tau need to be inverse in tau. So now it becomes R minus tau, the signal being flipped. Okay, so this is more or less similar as time inversion. So the signal being flipped. Next, the signal will be shifted to the left by t. Okay, this signal R tau, R minus tau, being shifted to the left by t. Okay, so originally it is 0, so now it being shifted to the left to t. Minus 1 being shifted to the left by t. So it becomes the range of t to t minus 1. So this is what you need to do to the second signal that you have decided to be used for further analysis. Okay, step 4, you need to place both the first signal and the second signal on the same axis or the same plot, and then you need to place the second signal a bit far away from the first signal, from the fixed signal, so that it is no overlapping between the two signals. Then you need to perform integration considering the overlapping area. Okay, so in this case, this is the signal, the fixed signal, and RT minus tau is the second one, the second signal that we choose to be moved from left to right. Okay, so we place them a bit away from each other to avoid overlapping. So in this case, you need to perform the first integration by using a convolution theorem given by this equation, RT convolve with ST. In integral theorem, it is equal to S tau RT minus tau d tau. So in this case, the range is from negative infinity to positive infinity. Okay, so when there's no overlapping, so the amplitude or the area that overlap is 0. So when you integrate 0, you get 0. So when there's no overlapping, basically the integration will produce 0. Okay, in the previous step, we have see when there's no overlapping. So the next step, we need to move the second signal to the right so that part of the second signal is overlapped with the fixed signal. Okay, so earlier we can see that this is the fixed signal. And then this is the RT minus tau. There's no overlapping in the earlier step. So now we move this signal into the fixed signal so that part of the second signal is overlapped. So we can see now part of the second signal being overlapped with the fixed signal. Okay, doesn't matter where you're going to place as long as part of the second signal is overlapped with the first signal. So now the range where the signal overlap is between -2 to t. Okay, so this is the area where the two signals overlap. Okay, so you need to do the integration. Okay, this is the general equation. So now the range that the signal being overlapped is from -2 to t Okay, and then the constant amplitude of the first signal is 2, and then the constant amplitude of the second signal is 1. So then you perform the integration. So at this point, at this range of t, the output is 2t plus 2. Okay, so how you get this ratio is, okay, when you look at the t, okay, in this case t is larger than minus 2. So this is the when t is larger than minus 2, but the t minus 1 is less than minus 2. So in this case t is less than negative 2 plus 1, t less than negative 1. That's why you get t larger than negative 2 but less than minus 1. Okay, next step, you need to move the second signal to the right so that the signal will be completely overlapped. Okay, we're going to look at that process in the next slide. Okay, next you need to move the second signal to the right so that the second signal is now completely overlapped with the fixed signal. Okay, so you need to perform integration over the overlapping area. Okay, so now earlier we have the signal just partly overlap, but in this step you have the second signal completely overlap with the fixed signal. Okay, this is the area in which the two signal is overlapping. Okay, it's from t to t minus 1. So how about the ratio? So obviously t is less than 2, but t minus 1 is now larger than minus 2. So t in this case is larger than negative 2 plus 1, t larger than negative 1. So that's why you get this ratio. Okay, so you can basically place the second signal anywhere inside the fixed signal as long as both of them completely overlap. But still, the range of t in which the two signal is completely overlap is between t to t minus 1. So now you do the integration. So in this case, the range of t in which the two signals overlap is from t minus 1 to t. So for the first signal, for s tau, so this is s tau, so it is constant 2 within the overlapping area. And for the second signal, rt minus tau, it is constant 1 within the overlapping area. So for the ratio of t less than 2 larger than minus 1, so yt is equal to 2. Okay, next step, move the second signal again until it is partly overlapped on the right, and then perform the integration over the overlapping area. Okay, we have seen the signal, there's no overlapping, and then move to partly overlap somewhere here, and then move again until it is completely overlapped, and then now move again to the right until it is now partly overlapped, okay, in this area. So now the overlapping area is between t equal to 2 and t minus 1 less than 2. Okay, so the overlapping area is t minus 1 until 2, and again the overlapping area, so for s tau it is constant 2, and for rt minus tau it is constant 1. So you perform the integration. Okay, so for this ratio, your yt is equal to 3 minus t. Okay, finally, move again the second signal until far to the right until no more overlapping between the two signals. Okay, so now the signal be moved from this position before this, from partly overlap to no more overlapping. So when you have your the second signal positioned here, so there's no more overlapping between the first signal and the second signal. So when there's no overlapping, so obviously the integration yields 0, no overlapping. Next, you need to summarize all the amplitudes or the output of yt for different ratio of t. Okay, so this is from the first state, the first case, no overlapping. This is when partly overlap. This is when completely overlap, and this is when partly overlap, and 0 again when no more overlapping, when t is larger than 3. Okay, so this is your output yt after convolution of signals rt and st. Okay, you can find more explanation on the convolution steps in this video, so please watch until the end. And also in the next slide, in the final slide, you will find more example on different shape of signal having convolution process as well.